So before we move on, let's make a small correction to what we just said from a question that came in during the break. So in this step, we want to divide by n. So we need to check that n is not 0. And actually, what we wrote down was technically wrong, because if you can let n be 0, then you can satisfy this for any row number. So let me just add the condition that n is not 0, and then we can divide by it. We are all good. So now let's continue to define functions. A function, or map, from a set A to a set B is an assignment of a single element of B to each element of A. So I might use this abbreviation for element sometimes. So we will write F colon A arrow B, or sometimes A arrow B F there. And we say A, in this case, is the domain of F. And B is the codomain. So if you see this prefix a lot, it just means you're flipping something backwards. So the one side is the domain, the other side is the codomain. So let's get into some examples already. There's a lot more definitions that I want to make about functions. So let's take this for now and do some examples. So multiply by 2 is an example of a function. And let's say it's a function from the integers to the integers. So for example, 0 maps to 0. Okay, what do I mean by this? I mean, this is the assignment of elements. So I'm telling you, when I say maps to, I'm telling you which element is assigned to that thing. 1 maps to 2, because when you multiply by 2, that's what you get. 2 maps to 4, 3 maps to 6, and so on. So for each integer, I'm assigning another integer, which is 2 times it. What's another example? We can get a function from the integers to the rational numbers by saying multiply by 1/2. Function from the integers to the rational numbers. And note that we could not put integers here because when you multiply an integer by 1/2, you don't always get an integer back. So in this case, Z is the domain and Q is the codomain. And I want to make a note of this, just to be extra clear about it. I've given these things names for a reason. So don't ignore the domain and codomain. So it's part of the data of the function. To give a function, you need to give some kind of rule for translating elements on one side to elements on the other side. But you also have to tell me what the sets are that you're going from and to. So for example, multiply by 2 you can think of this as a function from z to z, but you can also think of it, as a function with many different domains and codomains. So for example, from q to q, from z to q, and so on. And what I'm saying is, these are different functions. And they will have different properties. So for example, I guess I'll even be able to say an example a way that they're different in a moment. But even later, when we start talking about what it means for a function to be surjective and injective, that's something that these functions do not have in common. So let me say explicitly, functions are equal if they have the same domain and codomain, and the same assignment of elements. But in particular, for functions to be the same, they do have to have the same domain and codomain.